Our fourth and final method for solving a quadratic equation is the quadratic formula. Now, the quadratic formula is actually a foolproof way to solve any quadratic equation in standard form. So people are like, well, why don't we just learn that? Well, two reasons. One, solving by factoring when you can do it, super quick. Solving using the square root method, super quick. Completing the square is the quadratic formula. So I can prove to you that it's important to, well, let me rephrase that. I can prove to you that the quadratic formula comes from completing the square, which it's sometimes good to know where things come from so that you understand how to use it. So let me just show you the derivation. Now you're all going to look at this and be like, but it's cool. So what they've done is they've kept your quadratic equation as ax squared plus bx plus c, and then they've completed the square. So they divided everything by a, and then they took half the middle term and they squared it, and they added it and subtracted it, or added it to both sides in this case, and then they completed that square and then they made a common denominator, and then they took a square root plus or minus, and then they took the square root of the denominator, and then they subtracted this to get x by itself, and you end up with the quadratic equation. So the quadratic formula, I should say, is completing the square done for you, which makes it really convenient, but sometimes just completing the square makes the question easier, and it is good to understand the process. It's not always good to just plug numbers into formulas. So a quadratic formula is something you do not need to memorize. It is on your formula sheet, and it is negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient on the x squared term, b is the coefficient on the x term, and c is the coefficient, or not the coefficient, but the constant at the end. So what we've done here, what I've done here, is I've got 4 questions kind of done for you. Nobody usually messes up putting in a, b, and c. So I've given you an equation like 6x squared minus 7x minus 3 equals 0, and I've plugged in negative b plus or minus b squared minus 4 times a times c all over 2 times a. Same thing here. So be careful when an equation starts as x squared minus 4x equals 8. You have to have it in standard form to use the quadratic formula. So I've taken this one and I've subtracted 8 from each side to make it equal to 0. Then I've got a is 1, b is negative 4, c is negative 8, and I've plugged those in. The reason I've done this part is because that's not the part people mess up on. The part that people mess on is calculators. Can you plug b squared minus 4ac into your calculator? So what I want you to do is I want you to pause the video and I want you to take a second to go through each of these 4 questions on this page and just simply plug in b squared minus 4ac. My hint to you is you can write it as you see it, or a couple things. One, the b squared will always come out positive, so it doesn't matter whether you put this as positive 7 squared or negative 7 squared. The second thing is, if I was doing this question, I would actually type in 49 because I know 7 squared, or I could hit 7 squared. Then I look at my signs. Instead of having to take away 4 times 6 times negative 3, I could go, this is going to be a negative times a positive times a negative, which is going to come out as plus. So personally, I plug this in as 49 plus 4 times 6 times 3. But you do you. If you want to plug this in as negative 7 squared, great. If you want to plug this in as take away 4 times 6 times negative 3, great. What I'm checking is that we all get the same value underneath the square root sign. So take a minute, like I said, pause the video, and then I want you to get all of these values. All right, so hopefully you took the time to do that. I did, I paused the video. So what I got for this one is 121. What I got for this one is 48. What I got for the third one is 0. And what I got for the fourth one is negative 8. Now, this is going to be a thing that determines the nature of my solutions, or how many solutions and what they're going to look like. For this first one, what do you notice about 121? Hopefully it kind of rings some bells, especially after we did all that factoring. And you go, oh, wait a minute, 121 was a perfect square. So for this one, I could simply take the square root of 121 and get 11. And then I can keep simplifying. My answers would be 7 plus 11 over 12, which is 18 over 12. And then 6 goes into both 18 and 12 to leave me with 3 halves. And then for this one, I could do 7 minus 11 over 12. 7 minus 11 is negative 4 over 12. 4 goes into both 12 and 4 to leave me with negative 1/3. I got 2 rational solutions. What that means is that I actually could have done this one by factoring. If I hadn't used the quadratic formula, I could have said, what are two numbers that multiply to give me negative 18 and add to give me negative 7, which would have been negative 9 and positive 2, and then I could have done the whole decomposition method to then figure out that these are my zeros. Okay, so when the number underneath the square root sign is a perfect square, you get two rational solutions, and it means that you could have solved by factoring, but you don't need to. What about this one? Well, I want you to look at 48, okay? It's not a perfect square, but it is positive. And so I'm going to get two solutions. I would get two irrational solutions. Because I can't take the square root of 48 evenly, it means I'm going to be left with a radical in my solution. So is this my answer? Am I done? No. So with this question, it's not simplified. So what I could do is I could look at the square root of 48 and think, can I simplify the square root of 48? Well, the highest perfect square that goes into 48 is 16 times 3. So I'm going to simplify square root of 48 into 4 root 3. Now I've simplified my radical, but can I simplify this whole fraction? Now there's two ways to do it. One way is you could think of factoring. So out of the top, if I factor out a 2, I'm left with 2 plus or minus 2 root 3. And then I could also factor a 2 out of my denominator in a way, right? I could just leave it as 2. Since I have now factored and these are multiplying, this 2 is available to simplify, and I could be left with 2 plus or minus 2 root 3 over 1, which is just over. I can just leave it. The other way that I could have simplified, when I had 4 plus or minus 4 root 3 all over 2, is that you could actually divide by 2. I could have said this is 4 divided by 2 plus or minus 4 root 3 divided by 2. So the important thing to remember is that when you have a binomial or two terms in your numerator, each of them has to get divided by the denominator. So this would leave me with 2 plus or minus 2 root 3. So either way, when I get a positive number underneath the square root sign and it's not a perfect square, I always get two irrational solutions, and I should always make sure I've simplified as far as I can. All right, last two down here. For this one, I got a 0 underneath the square root sign. Well, what does that mean? Well, when I go to solve it, I've got 12 plus or minus 0, which means I just have 12 over 18. 6 goes into both 12 and 18, and I'm left with 2/3. What did I get? Well, when the number underneath the square root sign is 0, there's nothing to add and subtract, so I get one rational, because I got rid of the radical, solution. And then lastly, what if I get a negative underneath the square root sign? Now, if you go on to Math 60, you're going to have to do something with this. In Math 50, we can say, oh, there's no real solutions. Now we add the word real in there because there are two imaginary solutions, but we don't have to deal with those until Math 60. Now let me just sure I got that wording right. There's a thing down here that'll cheat for me. Oh yeah, no real numbers. So we can just say no real solutions. You could also say, right, or too complex. Don't worry about it. I would just say no real solutions. Okay. So let's practice. So we're going to do 3 from scratch with the quadratic formula right from the beginning. So for this one, I want you to pull off A is 3, B is 2, C is -8. And then I highly recommend start off by writing the literal formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Then start plugging in. Negative 2 plus or minus the square root of 2 squared minus 4 times 3 is a, negative 8 is c, all over 2 times 3. Okay, now simplify. I'm going to grab my calculator, I don't trust myself. So I would do 4 plus 4 times 3 times 8, but you can write it in as you see it, and we get 100. Nice perfect square. I get negative 2 plus or minus 10 over 6, which would give me two solutions. Negative 2 plus 10 over 6 and negative 2 minus 10 all over 6. So 8, 6, 2 goes into both to leave me with 4/3. 6 goes into both to leave me with negative 2. So I would have two solutions, 4/3 and negative 2. And again, I got two rational solutions, which means I could have done this one by factoring. Two numbers that multiply to give me negative 24 and add to give me positive 2 are 6 and negative 4. So quadratic formula can feel long, but if you're someone who's always struggled with factoring, you're like, yay, there's another way. All right, this one, before you can use the quadratic formula, the first thing you have to do is put everything on one side. So we're going to minus the 4x, we're going to minus the 7, equal to 0. So that tells me that a is 2, b is negative 4, and c is negative 7. And then plug it in. And again, I always start with my literal formula until I'm really sure I've memorized it. One thing to be careful of, make sure your dividing line goes across everything. So for me, I go negative, negative 4, right? And I make it a plus, but you could also just put negative bracket negative, but the less signs I write, the better. And then this is b squared minus 4 times a times c all over 2 times a. Now, if you haven't paused the video yet, try it now. So these ones are really complicated to simplify until you get the pattern of it. So the first thing you're going to do is simplify the square root of 72, and then look to see if you can simplify within the whole fraction. So for me, I go root 72 is root 36 root 2, which would leave me with 6 root 2 all over 4. Now again, you're looking to see if anything can come out of each term. So what can come out of 4, 6 root 2, and 4? Well, I can take out a 2. So I would go 2 times 2 plus or minus 3 root 2. And you don't take it out of the radical, just out of the whole number, divided by 2 times 2. So now I can simplify the 2, and I'm left with 2 plus or minus 3 root 2 all over 2. And that's as far as I can simplify. So remember from chapter 6, I can't do 2 divided by 2 unless I also divide this by 2, and I just leave it in this format. I mean, if you did answer 1 plus or minus 3 root 2 over 2, that's fine, right? I would totally accept that, but I think, if I can remember correctly, the textbook always answers it like this. All right, the last question I wanted to show is this one. To use the quadratic formula, it's just like solving by factoring. It has to be equal to 0. So the first thing we're going to do is we are going to distribute. I end up with r squared minus 7r plus r minus 7 equals 1. Then I'm going to minus the 1 from each side, and I end up with r squared, collect like terms to get minus 6r, and then I've got minus 8 equals 0. Now this one, when I'm looking at it, I really just want to complete the square, but it said solve by quadratic formula. Now another thing I did here is switch from x's to r's. So technically when you write your quadratic formula, instead of x equals, it would be r equals. And then again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative, negative 6. negative 6 squared minus 4 times a is 1 times c is negative 8 all over 2 times a. And again, if you liked it, write those down. A is 1, b is negative 6, c is negative 8. As you guys have discovered this far into the course, the number one place to make mistakes is integers. So try to prevent making those mistakes. All right, now we're going to simplify. 6 plus or minus all over 2, and we plug this into our calculator. 36. I get 68. Okay, if you didn't pause on the last one, give this one a go. The first thing you're going to do is simplify the square root of 68. What's the highest perfect square that goes into 68? 4. I'm left with 2 root 17. So I'm going to put 6 plus or minus 2 root 17 all over 2. Can I simplify? Is there something that could come out of the top that could also come out of the bottom? I can take out a 2 to be left with 3 plus or minus 1 root 17. So I'm just going to write root 17 all over 2 so that the 2's can simplify. And I'm left with 3 plus or minus root 17. Whew. So that's the quadratic formula, and that's as hard as it gets. Sometimes you get 2 rational solutions, sometimes you get 2 irrational solutions, or you can get 1 solution, or you can get no real solutions. So go and practice the quadratic formula, and then we'll do the next objective.